So I'm Raina Shirali, this is Nadia Rahman, Safwan Mazhar, Rishti Sa, and Faisal Hassan, and we're Team Heads-Up. So head-up displays have been around since the 1970s. They originally developed for use in military aerospace applications, and they quickly became used in a variety of applications. So one of the big areas that we've seen head-up displays being used is in automotive technology. So recently, they've been there for a while, but recently in regular or cars available for the ordinary consumer, they've been widely available. And so we wanted to develop a way for people who have existing cars to be able to incorporate the technology available in newer vehicles. So our project is a head-up display that incorporates a crash detection triggered emergency response system, proximity detection system, and then a display that intuitively captures the information for the user. So our project is composed of a main central HUD unit, a proximity sensors that go around the car, and then an Android app that people can use to configure the setup for the system. So the first semester we pretty much designed our project, and then the second semester we proceeded to build it. And we've tested it and confirmed that the crash detection system accurately predicts. It is based off of estimation theory using a Kalman filter that takes input from the accelerometer and the GPS unit, and then gives accurate crash detection data due to sudden deceleration. We also used proximity sensors built with ultrasonic sensors, and they're used to accurately detect proximity of vehicles and other moving objects on the sides and rear of the car.
But that's a ready module that comes from Arduino or something like that? You didn't have to actually design the circuit around the ultrasonic microphone? It looks modular from the photos, right?
Yeah. So, no, we built the entire circuit board in there, and it's just the microcontroller is like a small teensy board, which is a version of Arduino, but we wanted to get all the parts ourselves and test the parts ourselves so we could have a seamless integration. So that there is like the internals circuit board of the main unit kind of thing.
So you've been working on this for a year now, right? What would you change now that you have all this experience?
Oh, we would probably go with a PCB, definitely for second iteration, and maybe also use a stronger sensor and microcontroller, because the teensy does not have as much processing power as we thought it would. But definitely we would go with a PCB design.
Can you talk about the notification system, especially before major accident, right? So
Right.
How are you notifying them? And I know some cars do some vibrations and stuff like that.
Right. So
And
ours.
related to that, you got 90% accuracy, right? And I don't know how you sell the 10% shortage, right?
Right. Well, it's based off of the sudden deceleration, and it's also based off of so we have an accelerometer which calculates the speed, which then goes through a conditional statement that detects the crash. So based on whether that accelerometer is properly configured, it's off by like 10%. So the speeds are off, but the emergency response notification, like crash notification, is all visual. So it pops up on an LCD screen that like you have been in a crash, or there is like a object approaching.
So only visual, no
yeah.
audio
No.
warning or anything?
That would be something that we would implement a little like in the second iteration. Maybe put like a vibration in it, but right now we wanted to focus more on getting like the warnings all together.
Okay. The 90% crash detection seems low for a safety-related application by
This-
about 10x. It takes
Yeah.
99%. I mean, who wants something that's like, hey, you got a 1 in 10 chance of it not
That's true.
not working?
So this is a first part of an iteration exactly of the full testing, because normal car companies probably have like a full year or so to actually test their crash algorithm, and we couldn't actually test this in a crash scenario. So we're using very small like subset of data to detect the crashes. But that's
So what would you recommend to the people that were going to try to bring it up to 100%?
Probably use a like, don't rely too much on the velocity, and maybe use like a vibration sensor in it as well, because that detects a lot more accurately.
Thank
I
you.
have another question about the 90%. So it seems there's lots of different crashes, right? You could get rear-ended, you could get hit from the
Yeah.
side. So how did you calculate this 90% accuracy
We're doing
number?
it based on head-on collision, so not side or back, it's more just front.
So
So
what data set did you use to calculate this 90% accuracy? Like, how did you simulate the deceleration of a crash?
So we used like first like velocity between two specific velocities based on DOT like data that says a fatal crash, which is if a vehicle is going from 0 like 30 miles an hour and then stops, and then that amount of G's equates to about 5 G's. So if that G matches, then that's the true, then the crash detection alerts. But yeah.
Thank you. This is real interesting.